Okay, here we want to use elementary row operations to solve a simple linear system. We've already learned how to use the inverse. We've already learned how to use the elimination and the substitution method, but we can also use row operations. Now, row operations are a lot more commonly used when we have 3x3s and 4x4s in larger systems, but they can also be used here. So the first thing we want to do, we want to set up a matrix. First thing we want to do, we want to set up a matrix here. So we would like to set this up as 2, 3, and 1. And here, 1, 4, and -2. So what we did, we set up the coefficients, all right, and also the solution vector. So now we have to do this. Now, I always, when we're doing elementary row operations and we need this row echelon form, I always like to have my ones in the top left corner because it's easy to maneuver. All right, so the first thing I would do, I would switch row 1 and row 2. I think that's the best thing that we should do, switch row 1 and row 2. All right, let's move this right here. So I'll switch row 1 and row 2. Okay, so that would give us 1, 4, and -2, and 2, 3, and 1. So as you can see, we really just had the exact same matrix, but we just changed it and put the 1 in the top left-hand corner. It's just a lot easier to maneuver with. And it helped getting us in that habit. It helps us a lot later. Now, the opposite of 2 is -2. So what we would do here is I would say -2 times row 1 plus row 2 to give us a new row 2. -2 row 1 plus row 2 to give us a new row 2. Okay, and remember, we're still going through, that's 1, 4, -2. Now, -2 times 1 is -2, plus 2 will give us 0. -2 times 4 is -8, plus 3 will give us a -5. And a -2 times -2 is 4, plus 1, which will give us 5. So now we can see we've got the form that we've been looking for. That row echelon form where we have that 0 and everything in place. So now we can back substitute. I would say -5y is equal to 5. Therefore, y is equal to -1. And then I would back substitute and go into the first row. That would be x plus 4y is equal to -2. Substitute in for y, that is x minus 4 is equal to -2. And of course, we just use our algebra to solve it. And after we add 4 on both sides, we will get 2. So our solution, of course, would be 2 and -1. Of course, you could substitute everything back in just to make sure and check. So like I said, usually we use the elimination method, substitution method. We've looked at how to do the inverse, but you can also use elementary row operations. Once again, elementary row operations are a lot more commonly used when we have larger matrices and larger systems, but it works here as well.